Hello, we're Jonathan and Lucas. Welcome to Electroplating.
A brief reminder that the impacts of drugs are immeasurable.
Let's start by talking about the electrolytic cell.
An electrolytic cell is a cell that undergoes a redox reaction when electrical energy is present. This process, called electrolysis, is often used to either decompose a substance or plate a substance with another substance.
An electrolytic cell is made up of 4 components. The first component is a power source. The power source is made up of a battery which provides electrical energy to the chemical reaction. This is necessary for the redox reaction to occur.
The second component is the anode. This is the component of the electrolytic cell that's oxidized. It's positively charged because the battery takes electrons away from it. In our experiment, the anode will be the copper electrode. The third component is the cathode. This is the component of the electrolytic cell that's reduced. The cathode is negatively charged because the battery pumps electrons into it. For the purposes of our experiment, the cathode will be the paperclip.
The fourth component is the electrolyte, which in this case is the dissolved ionic substance. For our reaction, we will be using copper-2 sulfate as our electrolyte.
Here we have an absolutely beautiful drawing done by the brilliant Lucas Gover. On the top of this diagram, you can see the battery, represented as a rectangle with plus and minus symbols on either end. This battery provides power to the cell in order for it to complete the electrolysis reaction.
The arrows show the electrons being taken from the copper anode to the paperclip cathode. Note that the paperclip is made of zinc in this case. We used alligator clips to connect the copper anode to the battery and the battery to the paperclip cathode.
When in solution, the copper-2 sulfate dissolves into copper-2+ and SO and sulfate-2- ions, as shown in the diagram.
When the copper is oxidized, the anode becomes positively charged and attracts the sulfate ions. Likewise, the paperclip becomes negatively charged and attracts the copper-2+ ions.
When electrons are taken from the anode, the uncharged copper atoms are oxidized, resulting in copper-2+ ion. The copper-2+ ions that come to rest on the paperclip are then reduced to uncharged copper atoms by the electrons. A few things to remember. First, electrons always travel from anode to cathode. And second, the anode is always oxidized, (ox), and the cathode is always reduced, (red cat).
The materials we used were a 250 milliliter beaker,
Hydrated copper-2 sulfate,
alligator clips,
500 milliliter graduated cylinder,
deionized water,
a 9-volt battery,
a bottle,
a zinc paperclip,
copper electrode,
and a scale. Our first step is to measure 49.94 grams of copper-2 sulfate. This is the amount of mass required to make a 200 milliliter 1 molar solution.
Our next step is to pour 200 milliliters of deionized water into the graduated cylinder.
Now Lucas will mix this solution until the copper-2 sulfate dissolves. Good job, Lucas! Now Lucas is dissolving the solution further in a bottle.
The solution is complete!
Hello!
Okay, so we're gonna record over this. So here Jonathan is connecting an alligator clip to the copper electrode, which is the anode.
Now I'm connecting the copper anode to the positive end of the battery. The battery will take electrons out of the copper anode, causing it to be oxidized and positively charged. Fortunately, not everyone in our class understood the seriousness of this experiment.
Now Jonathan is connecting an alligator clip to the paperclip cathode and connecting the other end of the clip to the negative side of the battery. The battery will reduce the paperclip, making it negatively charged.
Now, after the camera comes a bit closer, we're putting the copper anode and the paperclip cathode into the 1 molar copper-2 sulfate solution. We'll keep it in there for an extended period of time to allow the copper-2+ ions that accumulate on the paperclip to be properly reduced.
And now for the big reveal.
Oh! Whoa! What is that?
That's copper plated onto the paperclip.